actually have two talks. I have a short one and then a longer one because I was supposed to take up 45 minutes. And that pales in comparison to what we just heard about somebody who spoke for 2 years. This is talk about urban heat island effect and global climate change. I don't know why I have so many words on this, but heavily urbanized areas tend to have a higher outdoor temperature because of the heat island effect. And that's because of the fact that hard tops absorb energy and then radiate it back, and you have less tree coverage, etc. So this urban heat island effect is generally like 2 degrees or 4 degrees, between 2 and 4 degrees in an urban area compared to what you have in rural areas. The thing is that we've recently taken steps in Austin, and I've had a minor role in this, about increasing housing density. Home 1 and Home 2 were two ordinances that Leslie Poole suggested about allowing up to 3 housing units on each lot and shrinking the minimum lot size from 5,750 square feet to 1,800 square feet. We've also increased the density along the routes of the light rail. I'm not sure what the timing for that is because, it's going to take years to build the light rail, but that should start running in, I think it's 2033. And then also we relaxed the compatibility standards. And I know that not everybody is happy about these changes, but I want to convince you that it's a good idea. And that's because if you look at this website, the University of California at Berkeley has a website called Cool Climate. And what they've done is they've calculated the greenhouse gas emissions per household by zip code all across the United States. And when you look at Texas, for example, this is the, pardon me, President Trump, this is the Gulf of Mexico. And here's San Antonio, here's Austin, here's Houston. And the blue areas have the lowest greenhouse gas emissions per household in the most urbanized area. And this is because in your urbanized area, you have more shared walls, and that saves energy. You tend to have destinations closer together. The more rooftops there are, the more likely you are to have a grocery store nearby or a drugstore or a convenience store. So trips tend to be made on foot, by bike, by scooter, or if you're driving, they're still shorter trips. But then it's in the suburbs where you have single-family housing and you have low density, the greenhouse gas emissions per zip code go up. And so the point is, we're trying to densify Austin more the reason isn't to control greenhouse gas emissions, but it's a positive side effect. So anyway, you can look up this the subject of urban heat island effect by looking at this website. And one way to address it, and we can do this as we densify, is have more green roofs, and then also plant more. And green roofs can include topsoil in which you actually have trees. There's a few examples here in Austin. And then, again, I mentioned here, the effect in Austin is not large. And to give you an idea about this, I took the data from all of the TCEQ's monitors around the Austin area, and I looked at the average temperature from, what was this? I looked from between May and November of 2023, because that's when we had the most monitors available. And you can see there's not much variation. Everything is between 78 degrees and about 80 degrees. So there's your 2 degree difference between Dripping Springs and a place like Weberville Road or East Austin, which are the more dense, more urbanistic locations. But then I also looked at summertime afternoon temperatures. And so this is from May to October 2023, from noon to 5 p.m. And you don't see a 2 degree difference that's related to where you are in an urban versus a rural area. So the point is that the urban heat island effect is hard to detect in Austin, and a denser city is a greener city in terms of greenhouse gas emissions. So basically, that's all I have about this subject. But I had given this talk at the Environmental Commission about getting them to support Home 1 and Home 2, and they did, based on the fact that a denser city has lower greenhouse gas emissions. So are there any questions about that, or did I? Yeah, ma'am?
Real quickly, go back to your previous slide. Audubon, I'm not familiar with, is there a city name?
No. The Audubon site is, why aren't you on this? Oh yeah, here it is, right here. So it's a rural area. This is Lake Travis right here. So it's just north of Lake Travis. And they measure, the coloration here indicates, I don't have I have this in my next talk, but just so you know, a lot of these ones with the blue and yellow, that's ozone and meteorology. Because ozone is like the celebrity pollutant, and then meteorology is important to see which way the wind is blowing, what the temperature is, that kind of thing. And so these are the rural sites around here. And again, when I went to look at the temperatures on summer days, well, the lowest one is an urban site. And the second lowest one is the Audubon site. So, you know, where's your urban heat island effect?
It's wildlife refuge, right?
Yeah, yeah.
Wildlife refuge.
Yeah.
Question, a couple years ago, a hailstorm wrecked my asphalt roof, and I replaced it with a metal roof that reflects. Is there any positive impact of having reflective roofing on homes?
You know, that's such a small scale. I don't know if we would see an effect about that. I mean, a lot of the solar panels that you have on rooftops do reflect. So, and yet they're positive because they're generating electricity. Is yours generating electricity, or it's simply reflecting light?
Well, both. I mean, I have solar panels, and then the remainder of the roof is metal. So.
Right. I don't have any information about that, but again, it could be a part of the heat island effect. It's not my specialty, basically, but I could get back to Phoebe and Dick about that and have them relate that to the community here. All right, so my next, oh yeah.
So the monitoring we did, even in between grass and forest, we got 9 degrees peak summer temperatures. That's the highest summer temperature, which is one of the concerns. 9 degrees, and then open soil, we got 40 degrees hotter in the peak summer temperatures. And so I'd be really 40 degrees hotter, yeah, Fahrenheit.
Mm.
So I would be really surprised that asphalt, because I could tell you from stepping on bare asphalt, it's pretty hot.
Yes.
You know, so I suspect that it's not peak summer temperature. I was wondering if you read this stuff from the meteorologist who wrote the Elias, who likened the heating of the grasslands in central Texas to creating anticyclones, which we call heat domes now, that the earth was forums to the east, and how that might affect our rainfall and our water supply as well.
Yeah, I don't know. I mean, one thing I say about rainfall is I know I'm a Texan because I thank God when it rains. Where I come from, it rains all the time, but here, you know, you got to be grateful for it. But yeah, you'd have to talk to somebody who's more of a, you know, a geoscientist for that. I mean, I don't study the weather that much. I look at the measurements, and I'm a numbers guy. So forgive me for that. Yeah, Kurt?
It's kind of a two-part question. So, you know, having trees is good, but how are they going to enforce that? My neighborhood, the developers are cutting down all the trees, driveways.
Well, I mean, we have tree rules. There's very specific.
Developers aren't following because they can cut it down and get fined, and it's less. They make more money by doing that. And the other part of this is adding more density. In my case, especially, I'm at the bottom of the hill, 14 houses above me on the street. It used to take an 8-inch rain for me to flood. Now, I flooded yesterday.
Right.
And you know, my neighbors next to me have a 3,000 square foot house where a 601 square foot room used to be. They put in a French drain, which drains, you know, in violation of Texas water law, drains directly to my property and floods my neighbors. That's what I'm worried about, the density.
Right, but again, what we've done is we've kept the impervious cover the change. It's still 45% impervious cover. We have not changed the rules about trees, what are protected trees, and where you have to get a permit for cutting. And then very often when they do cut, they have to put in replacement trees, like a large number of smaller trees, but the inches add up to what was cut down.
Well, there's a loophole there because you don't have to get a permit to do landscaping. And what's happened, what I'm seeing, like, they just put in these big limestone blocks in the grass.
Right. Well, let me say, I'm a good person to talk to about this because I'm on the Environmental Commission. So talk to me about this later or email me. I got my emails. My city email is right here, bc.davidsullivan@austintexas.gov. So let me move on to this next subject about particulate matter. This is more of the science in which I do know stuff. And I got a couple of colleagues here from the TC, former colleagues from the TCQ here too, so they know about it also. So anyway, where's Raphael? I'm not moving the. Raphael, I'm not moving the. Nope. There we go. All right. So the US EPA, up until, I guess, January of 2025, the US EPA regulates air quality, and they have 6 what are called criteria pollutants: ozone, carbon monoxide, nitrogen dioxide, sulfur dioxide, lead, and particulate matter. And with particulate matter, there's 2 sizes of particulate matter. And these numbers here represent the aerodynamic size in terms of microns. So 10 microns and 2.5 microns. And I'll give you an idea what that means here in a minute. So particulate matter is in different sizes. The largest size is total suspended particulates. And that's something that we necessarily don't breathe into our lungs, but it's important because that's how we measure lead. Lead is a very important pollutant to control because of the health effects of it. And so these monitors collect for 24 hours large particles, small particles, all particles, and then this filter gets sent off to a lab where the lab looks at the makeup of what's on the filter, and they look at how much lead is there, and that's how we regulate lead concentrations, is through this type of monitoring. But then there are other instruments out there that filter the air only to get smaller particles, and we have means to do that that are called cyclones, where the air gets drawn in and the heavier particles fall out, and you're just left with the lighter particles. And so we can separate those into the 10 micrometer size and below, and the 2.5 micrometer size and below. And then we do this for 24 hours, where the air is drawn into the sampler, and then you take out the filter and you send it to the lab, and the lab weighs the filter, and then we know what the particulate matter concentration was. We can also take the filter and analyze it to see what was on the filter in terms of what the chemical makeup was. And then there's newer technology where we can measure the particles instead of putting it on a filter and measuring it for 24 hours and then sending it to a lab. The instrument can automatically measure the particles that come in, get captured on a tape, and then you blast that tape with electrons called beta particles, and the reflectance and absorbance tells you what the concentration was. And so then we can get hourly measurements of particulate matter, but we don't know what it's made of. We simply get the hourly measurements. And then comparisons between this method and the filter method come out to be relatively good. So we know that it's accurate. All right, so as an example of total suspended particulates, it's a wide range of sizes. This is a cow caught in a tornado. That's an airborne particle, but it's pretty big and it wouldn't get captured in any of our instruments. But this is what we're really looking at. This is a human hair must have been a pretty large person to have hair that big. No, I mean, But, the human hair size is generally 50 to 70 microns in width, diameter. And then the 10 micron particles would fit about 5 of them across. And then the 2.5 microns would fit 4 across one, 10 micron particle. So these are pretty small particles. And the reason why these are important is the smaller the particles, the deeper they can get into your lungs. Like the total suspended particles, many of those are caught in our noses and our throats, and then we cough them up. But the smaller particles go into our lungs. And that's why they're important in terms of, what they might do to us. This is another example right here, the 9 micron sand particle, 90 micron sand particle. So again, that's about the same, on the same scale of size as a strand of hair. But it turns out that these fine beach particles go down to much, much smaller sizes. In fact, one thing I'm going to talk about here in a few minutes is the fact that these micron-sized particles of sand can get picked up by the wind, and the heavy particles drop out, but the lighter particles get carried thousands of miles. And I'll show you that in a little bit here. So the reason why this is important is because just last year, EPA lowered or strengthened the the PM 2.5 standard from 12 micrograms per cubic meter for the annual average for the year to 9 micrograms per cubic meter. That's the measurement we use, micrograms per cubic meter. It's a concentration. Grams per meter, micrograms per meter. So anyway, they strengthened it a significant amount, which has a big effect, as I'll show you here in a bit. And then you can look link these up to see what's going on. So anyway, this is the PM 2.5 and PM 10 standards that exist. And so it used to be 12. And what it is, it's the annual average over a year. And then it's 3 years averaged together. And that's called the design value. And then that design value gets compared to that number 9. There's a secondary standard that is a health standard, but it's used for looking at it. It's still considered a problem if you're above that. But it's not held against you as sternly as if you're over the 9 microgram level. And then there's another one at just how often you get very high concentrations. So this 35 microgram per cubic meter, 98th percentile, you count how many days of the year you're over 35 micrograms per cubic meter. And then if you sample every 6th day, then you've got 60 samples in a year. Your third or fourth highest value would be your 98th percentile. And that's got to be less than 35 micrograms per cubic meter. And then PM10 is a much higher standard, and that really hasn't been a problem. All right, so the TCQ breaks the state up into regions, and we're here in Region 11, Central Texas. The air quality standards are based on MSAs, Metropolitan Statistical Areas, or CMSAs, combined Metropolitan Statistical Areas. So, for example, Houston is a CMSA because Galveston is one and Harris County is another. So they're a combined MSA, whereas Austin is just Austin. And San Antonio is just San Antonio. Corpus Christi and Victoria are just one. So anyway, here's the monitors, again, that I showed you a little bit earlier, but I'm showing a larger area. This is all the monitors in the Austin region, which includes Hayes County, Williamson County, Burnett County, and Kaufman County. And so we got monitors over in, again, these blue and yellow ones are ozone and meteorology. So there's one over in Bastrop, there's one in Elgin, there's one up in Taylor, there's one in Round Rock, there's one down here in San Marcos, there's one in Lockhart, there's one in Kyle. And those just measure ozone and meteorology. But then here in Austin, here we are, here more locally, and you can see a wider variety of things that are measured. So up here at North Hills, we're measuring ozone, meteorology, nitrogen dioxide, particulate matter 2.5, and what's the light green? Oh, sulfur dioxide. And here up on the IH35, this is a program that EPA kicked off a few years ago, putting monitors right on major highways in order to see what the exposure was. And so there's ozone, meteorology, particulate matter, and both PM 2.5 and PM 10. So anyway, this is what a monitoring station looks like. You can see this. This is the site up off of IH35. It's a trailer surrounded by a fence. And this instrument right here is measuring particulate matter. There's a 10-meter tower that measures meteorology. It has a wind vane and a wind vane and an anemometer at the top. It measures temperature. This is where the air is drawn in from the outside. You don't want to draw it on from the ground because, it could be dust or whatnot. But, to get a good reading for what's in the region, you draw it from a few meters up in the air. And anyway, there's about 200 of these scattered around the state of Texas. And this is the one that's up off of I-35. And then go inside. These are the monitors that you have inside. It's very clean. You've got a fuse box over there for all of the power. You've got individual instruments here in this picture measure ozone, carbon monoxide, sulfur dioxide, calibration equipment, etc. So this is what the inside of a monitoring station looks like. So why are we measuring particulate matter? Well, again, because the size of the particles that get into your lungs, it's not a good thing. Numerous studies have linked particulate matter pollution to a variety of problems, including premature death, heart attacks, irregular heartbeat, asthma, decreased lung function. Whoops. Yeah. Occasionally the monitor will go out. Oh, come on. Yeah. So anyway, and there's a website called Air Now, which you can look at if you simply Google AIRNOW. You'll come up with an EPA website that has information about all this. Yeah? Well, yeah, so the question was, with all the growth in the state of Texas, is 200 monitoring stations enough? Well, first off, there's large areas with a very small population, and there are no monitors in those counties. Almost all the monitoring is located in your urban MSA areas, and they're distributed in such a way that they're supposed to be indicative, each monitor is supposed to be indicative of a large area. So it's not like you put one right next to a factory and that's all. You've got them in neighborhoods, you've got them at schools. In fact, schools are an excellent place to put monitors because you have wide open area and your most important citizens are children. So anyway, we can't put them everywhere. Each one of these stations costs probably like $100,000 to $200,000 in terms of the equipment that's in them. So there are financial readings. But I'll tell you, we have a lot of monitors that I think other states are, in part because of all of our industry here, we've got more monitors probably per capita than many other states. But I haven't checked into that, but that would be my supposition. All right, so I'm going to tell you about what we see in the particulate matter. Turns out that I only have data from 2021 to 2023 because when I pulled these data last week, the fourth quarter of 2024 was not available for downloading. When data are collected, it goes through a validation process, where human beings look at it to make sure that the instrument was looking right. They look at all the readings from the instrument, and then they look at the numbers to make sure you don't have like big negative numbers or gazillionly large numbers or something like that. So anyway, they had not validated the fourth quarter yet, so I didn't include 2024 in what I'm about to show you. The NAAQS determination, that's the National Ambient Air Quality Standards, is based on 3 years of complete data. The way we judge it is we look at the data by quarter of the year, and we make sure that we've got at least 75% of the samples that we wanted in each quarter. And then we take the 4 quarters of the year and we average those to get a full year. And then we take the 3 years and we average those to get a 3-year average. And so that's what I did to do this. And here's the results. And you can see up there at the top, I've ranked these in order of the design value from 2021 to 2023. And the very worst location is in El Paso at Escarate Park. This is a site right near the Rio Grande, Rio Bravo River in El Paso. And that's over 12, which was the old standard. So there's only one site that is over the old PM 2.5 standard. But there's all of these sites are over the new 9 microgram per cubic standard, including 2 locations in Austin at Weberville Road and up off of IH-35. And then there's another site up at North Hills Drive in Northwest Austin that's only 8.7, so it's just a little bit below. And then this Jarrell site, that's a rural site up in Williamson County, and they have they're the lowest, cleanest air in the region for this. But you can see the range of concentrations here. It's kind of funny. The cleanest place is Lubbock. Yeah, Roy?
Yeah, on the El Paso, that's El Paso, is that including what comes across from the other side of the river?
I'm going to get to that. Okay? Right. So anyway, so this is an important point that we've got a number of areas that are non-compliant, and that's a different word than non-attainment. Non-attainment is a legal definition, a legal term that EPA uses where they start to impose penalties on an area or requirements on an area. But you can be non-compliant and they don't do it because of some other reasons. And among those reasons is Section 179B of the Clean Air Act, which I know everybody knows about that. That's the section of the Clean Air Act that says an air agency has the authority under this section to develop and submit to EPA a demonstration that its state implementation plan would be adequate to maintain the NAAQS, but for emissions emanating from outside the U.S. So, when you look at places like El Paso and Laredo and all the border communities, and I mentioned Laredo because I have a project measuring particulate matter in Laredo, so I'm watching this closely. It's you have to expect that you're going to get stuff come from outside the U.S. Well, it's bigger than that. It's much bigger than that. We get smoke from agricultural fires in Central America and in southern Mexico in the springtime, and we get airborne dust from the North African deserts, the Sahara and the Sahel deserts in North Africa, visit us in the summertime. And as an example, here's some data from Corpus Christi, because I used this from a report that I did in one of my projects, where you can see these 2 very high values right here on June 26th and 27th, 2020. And what the TCEQ does is they forecast a few days in advance about what the air quality is going to be in Texas. And you can sign up. You can go on the TCEQ's website and you can sign up to get an air quality forecast. And the forecast for those days said heavy amounts of African dust will arrive along the coast and begin moving inland over the course of the day. And that's in fact what happened. And so those 2 days are probably 2 days that would not be counted in the annual average. Here's the same thing for Austin, the same 2 days back in 2020. And again, it's not nearly as bad. Like it was up around 70 and 75 and 60 in Corpus. And then here it was 60 and 38 here. Because it's farther inland and whatever pollution came in dispersed more. But again, it's the same 2 days and the same forecast for here. Well, anyway, I put this in a report recently, and the whoever I was writing the report for came back and said, "Well, that's from 2020. Don't you have anything else you can give us more recently?" And I looked in and I said, "Yeah, this is the same thing right here in July or late June of 2022, and I had data in 2024, and there's days like this in every year." So this is, say what?
Do they calculate wildfire smoke?
Not if it's in the U.S.
Well, I mean, like that's not they have.
Well, that would still count against. There's another section in the Clean Air Act for what's called exceptional events, and an example of an exceptional event is obviously the 4th of July. I can tell you that the monitors in Northwest Austin go off for particulate matter it's either on the 3rd or the 4th of July, whichever night they shoot off the fireworks down on Lady Bird Lake, and the smoke is blowing from the southeast and it's going northwest. It hits those monitors, and they will not count that. And the other one is New Year's Eve. Oops, sorry, pardon me. On New Year's Eve, they don't count that. So it could be that the wildfires fall into that also. But anyway, this is an illustration that was in one of the TCEQ's publications. This is, where am I? Oh, there's Florida. Here's the Gulf of whatever, depending on your political leanings. And this yellow is what the overhead satellites saw looking down as dust moving from the east to the west across the Atlantic Ocean. And the TCQ meteorologists have access to these photos from NOAA, National Oceanographic and Atmospheric Administration, and they use those in their forecasts for particulate matter, as well as the other forecasts they do for ozone and other things. So anyway, we've got strong evidence. This is on the 24th of June, 2020, which is the example that I was showing from before. And again, this is what the data looked like in Austin on the 26th and the 27th of that year, where the concentrations were low in the morning and then hit 80 at 2 different monitors at the same time, which probably means it came from far away because it was coming into the area as one big lump. And then the next day, the same thing. They're a little bit spread apart, but still concentrations way up in the 90s when the standard is only 9. All right, so what's NPM 2.5? A number of the stations that are out there, in fact, I've got one running in Laredo. What you do is you take the filter on a sample, and then you take the sample and you send it to a lab, and the lab does different procedures on it to determine what made up the particulate matter on the filter. Generally, the analysis looks at a whole array of elements, and then ions like ammonium, sodium ion, potassium ion, nitrate ion, and sulfate ion. And then some things, some carbons, like elemental carbon is just carbon. And then organic carbons would be like some hydrocarbons that don't get broken down, but they come out simply as total OC or total EC. And then given a matrix of all of these pollutants, when you have enough of them, enough days where you've got these data, you can use mathematical multivariate methods. I love saying that because that's what my background, my math background, and you can derive what the source factors are. There's a method called principal component analysis or factor analysis, but then there's more elaborate methods, chemical mass balance and positive matrix factorization, which I'll show you the results of here in a second. So anyway, this is what you get when you take the mix of those elements along here, elements and ions along here, and what were the concentrations of them, and how did those concentrations get mapped to different categories that would be the factors that make up the particulate matter. And so ammonium sulfate is a sulfate ion and the ammonium ion, and that generally comes from power plants. SO2 gets emitted. There's sulfur in coal. You burn the coal, the SO2, the sulfur goes out the stack, it reacts with oxygen in the atmosphere, and you get sulfur dioxide. Fires, you get organic material, but potassium is a good signal for what you get in fires. But you get the organic carbon, the OCTC there, and the ECTC. And then potassium is K. So you get that in both ion form and elemental form. And then you get some other elements also. And then ammonium nitrate, where do we get that from? That's from, that's an industrial factor. And then crustal material is aluminum, silicon, iron, and potassium and tin. So anyway, your metals and whatnot go into crustal material. And then we also get sea salt, which is kind of interesting. You see sodium and chloride and the sea breeze kicks up sea spray into the atmosphere, and then some sodium and chloride gets absorbed into droplets that go into the atmosphere and then get blown onto shore and then get deposited in our samplers, and we see sodium and chloride. And then there are two factors for motor vehicles that can often be separated and often not, but heavy-duty vehicles and light-duty vehicles. And so when you look at, this is from Corpus Christi, because this is where I have data. I don't have data yet for Austin or for Laredo, but we've been doing this in Corpus Christi for a long time. And it just gives you an idea about what's in this particulate matter that you're breathing in. And so about 19% of it's crustal material, meaning it got blown up from the Sahara Desert and transported across the Atlantic Ocean. Or it could have been from that parking lot that a heavy-duty vehicle just drove through and kicked up a bunch of dust. And then there's the motor vehicle, which we all are aware that when you burn gasoline, you have incomplete combustion and you get some crap come out the tailpipe. And then fires, which could be a forest fire, could be a house fire, could be the agricultural burning. Ammonium sulfate, likely from power plants. Sea salt, if you live near the coast, we don't see that much of it here. And then ammonium nitrate is a small amount. And you don't get this add up to 100%. I got this to add up to 73% of the total mass at Donna Park in Corpus Christi, but that's pretty good. All right. Yeah.
Those profiles is only produced by the thing that you have listed underneath it. Nothing else is produced, say, the profile for an HPV other than HPV.
No, you could have other things produce it. For example, the like ammonium sulfate, I blame that on the sulfur that's in coal that gets burnt. Well, they've taken a lot of the sulfur out of coal now. In fact, we see very little sulfur dioxide in the atmosphere now almost anywhere. But we still see ammonium sulfate in particulate matter. So it could be that it came from a ship in the Gulf that was burning fuel oil that had sulfur in it.
But nevertheless, it comes from ammonium sulfate.
Yes. Yeah. The production could cause it also. Yeah, I mean, that's the thing, that there's a wide range of sources out there. For a long time, we blamed it on the sulfur in coal, because there was a lot of sulfur in coal. I'll tell you, one time I was doing a mobile monitoring trip where we put the instruments in the back of a Chevy Suburban. We run the sampling line out the roof, out the window, and onto the roof of the vehicle. And then we go out, we drive around. And I'm driving just east of Austin, and we get a hit of sulfur dioxide. I look out my window, I see the LaGrange power plant. We continue down the road, we turn left, and we're going north now, and then we come back west again, and I get another hit of sulfur dioxide. I put those two hits on a map, I draw a line based on the wind direction, and it went right back to the Lagrange power plant. So that was like 20 years ago. I mean, that was maybe not that long ago, maybe 15 years ago. But they've done a lot to take the sulfur out of coal now.
If you have your sensor, you have it at 10 feet or you have it 30 feet, will you get a different reading?
Possibly. These particulate samplers don't take it at 30 feet. The wind is measured at 30 feet. The samples are taken at 2 or 3 meters. That'd be 6 feet or 9 feet. You could get different results, but not very greatly different. I mean, the whole point, we go to great effort to make sure that samples that we take are representative of a large area. And so when I was doing mobile monitoring, I was sampling over hundreds of miles on a driving trip, but I did pass by individual plumes. It's hard to do that with a monitor that's fixed in place, but occasionally you would see that plume hit that monitor. All right, so I'm almost done. What else do I have? I was going to say something about what's in the North African dust. Well, there's a little formula here that we came up with for a paper that we did. You don't have to worry about that. When do we see it? Well, this is when we see the crustal material pop up in between. See, that's June, that's July, that's August, and that's September. So it's 3 months of the year that we see the crustal material, which is our highest PM 2.5 issue. And then there's a lot of literature on this subject, which if you had this PowerPoint, you could look up these articles. But hey, there's my name. So this is one that we did. But so here's another one of the points, though. In an earlier paper that some of my coworkers did, they looked at, well, what happens when you take the outside of the U.S. concentrations out of the averages? And so you can see that there's a pretty good bite that's taken. Here they were looking at the 12 microgram standard because that's what it was. But here's one that's like a full microgram per cubic meter. That's a huge amount that would be taken out in 2014. So anyway, we haven't done this yet, but I'll probably do it at some point. But it's not my job. It's EPA's job to do it. Like the state will put in the protest to EPA about, here are the days that we forecast North African crustal material or dust to come in. So take those days out of your calculation. And if EPA agrees, and we've got the evidence with these satellite views, then they will they'll take those days out. And so there's a pretty good chance that we will come into compliance once that happens. And then here's a question. This is why I gave this talk at the Environmental Commission. Is IH35, widening IH35, going to have an effect? Well, when you look in the environmental impact statement, 11 times fugitive dust is mentioned in the environmental impact statement. And so there are these statements in there that I pulled out. To reduce the dust, the contractor will develop and implement construction dust abatement program, et cetera, et cetera. So they'll use best management practices to be implemented to minimize the amount of dust. So will there be a problem created by the expansion of IH35? I think there will be. But we'll see how well they can contain the dust. And I think that's all I have. So, yep.
I have heard that TCEQ turns off air monitors near a chemical or oil and gas plant when there's an accident, so no one can see how much pollution there was. Have you heard anything to that effect?
They didn't do it when I worked there. I mean, I worked there until 2005, so I don't know what they do now. I can tell you too that they have cut off. They like 2023, they had more monitors out there than they had in 2024, which is one reason why I've done more work with 2023 data. But I don't know if they did it for some reason. Yep, Nico?
So there's a U.S. Forest Service study that showed it actually quantifies how much the forest and soil takes of contaminants. I don't know if you saw that, but it quantified like Travis County, it takes in fairly rural areas, it takes 96% of particulate matter to get it to more. It doesn't happen in the urban areas.
Mm-hmm.
So I was just wondering about too the mercury. You know, like 20% of the incident mercury is from wildfires and described burns. Phosphorus, you know, it's introduced toxic.
Yeah.
And the other thing I was wondering about is that, you know, the city of Austin, for example, burns about 2,000 acres a year, 1,000 here in Walter Long. You mentioned
Prescribed burns.
This is kind of the high burning time of the year for other burning that goes on near the Travis County, Case County border. Between December and February, they burn about 1,000 acres. Which is recently had one on, you know, Long Island. So I was just wondering, I know the Environmental Commission, you know, recommended the prescribed burn that they have monitoring for
Yeah.
September 2023. And so I was wondering that, you know, and I know they have purple air monitors too.
Right, that's a cheap, low-cost monitoring project. Yeah.
Monitors. And I was just wondering, none of the monitors are like east or northeast, because of triggering the wind direction from those prescribed burns. And I know the, you know, the University of Texas and Nature Conservancy also burns. They had a prescribed burn in part in February of 2024, and it kind of response to Senate bills. And so I'm just curious why the monitors, I know you already recommended that, and I thought the details were adopted that, why they aren't downgrading the prescribed burns.
I don't know. I'll look into that, though. Really, that's a great suggestion.
Dr. Nico Howard.
Right. Did everybody get that about why prescribed burns don't do monitoring like right downwind of a prescribed burn? I don't know. They should.
About 1,000 acres on Austin water side near the Travis Case County
Yeah.
border.
We have a traveling microphone. We should probably have people asking questions. Yes, I'm wondering how it is that the particle sizes, 10 microns and 2.5 microns, were chosen as upper limits for measurement. Is it because of something about the measurement technology?
No, it's about the penetrability into the lungs, basically. The 10, and again, this is what's called an aerodynamic diameter. It's based on like how would a round particle of water react. But a lot of particle sizes are, you know, strangely shaped the way I showed when they showed their crustal material. So it's an approximation. But the idea is that the smaller the particles, the more deeply they are taken into the body, and then from the lungs go into the bloodstream. The 10 micron particles are more likely caught in the throat, and maybe they don't get absorbed into the body as well because they're a little bit bigger, but they can still cause problems. So they introduced they first had a TSP standard, and then they made it a 2.10 standard, and then they introduced a 2.5 standard. There's actually a 1 micron measurement that's done. A lot of people are doing just because they know that there are particles that are ultra fine, and they're trying to see whether they are a problem.
3 micron particles going into my body, I'm cool.
If you have what size?
3 micron.
No, not necessarily. Because again, it's an approximation. They have to do something, you know, draw a line someplace. So it might be the case that it's a statistical thing that 100% of 2.5 microns go in, maybe 40% of 3.5 microns go in, you know, something like that. Yeah, that's just a guess. This lady here in the orange. Well, this lady had her hand up first.
Go ahead.
All right, so I'm an infectious disease physician. This is very interesting to me because as we've seen global warming, we've seen a lot more dust, and I know you mentioned a lot of clinical conditions that can occur from that, but we have some very specific maps of what we call endemic mycoses, which are fungus infections that occur in certain areas. Histoplasmosis is one that used to be very much in the Ohio River Valley. But as we were getting more dust, that map is completely global. Coccidiomycosis, where we used to see that in, Arizona,
Right.
it's coming our way. So it's very, very interesting, this phenomenon of having these dust particles, because they're creating a lot of more clinical disease. I mean, it's not unusual for me to see histoplasmosis in Austin.
Right.
Very, very terrible.
Well, the thing I would wonder about is the organic carbons, that where we're not differentiating it into individual species. We're lumping all the hydrocarbons into one organic carbon component. And that's one of the things that we're related, is concerning about carcinogens.
Well, not only carcinogens, but fungal infections. And I think that map, we're starting to learn a lot about that, but it's really important, and it kind of highlights global warming and the more dust we have, where all of us are at risk. And it's very important because we're entering an era where you have psoriasis, you see all the commercials for biologics. Those patients are getting extremely ill due to these. So I really appreciate your talk about these dust, particles, and that they're really carrying a lot of infectious diseases that we had really situated in certain areas, and now they're becoming very commonplace.
Well, I'm going to ask about that because, again, we look at the elements, the ions, the combined EC and combined OC. We're not looking for particular germs. But, and again, I'll never forget when one of my colleagues at the TCEQ, was Brian Lambeth, said, why are we looking at these trace gases instead of looking at allergens, which are a bigger problem for people? But again, that's a good question. Not just because they're nuisances, but they can be serious health threats. Yeah?
Is there a possibility of looking for microplastics?
I don't know how big of a problem that is in the air. I mean, you would see that in the OC, the organic carbon. Yeah, Dick? Oh, let me get Scott Johnson first.
Dave, I'm aware that monitoring and all the other scientific work is necessary. My question is, can you connect high ozone or high particulate matter readings over a period of time with action that's been taken to modify a plan such as the Central Texas Regional Air Quality Plan or any other plan in terms of actionable steps that have been taken due to high pollution level readings?
Well, first off, let me say this. Air quality is much better than it was before I had gray hair. When I was younger, ozone concentrations above 200 parts per billion were not uncommon. And now the standard is at 75 or 65, I forget. And it's much, concentrations are much, much lower that we see because we've been very, very, very successful in cutting back on emissions from motor vehicles, power plants, utilities, etc. But we still have problems because EPA keeps making the standards stricter, and that's important because there are still health concerns even at these lower concentrations. So, but I don't know the answer to your question. Yeah. Yeah.
I always heard that the detritus from African deserts caused a hurricane season in the fall. Is that the same stuff?
No, I mean, the period that I showed was peaked in July. And it's dust that blows, it picked up into the air. Heavy particles drop out as it's coming across the Atlantic Ocean. The fine particles remain suspended in the air and then come into the Gulf of Mexico and blow into Texas and Louisiana. I'm not aware of that.